This tutorial is on statistics, and in particular, we're going to focus on samples and populations. First of all, let's look at populations. The set of all eligible members of a group that we may intend to study is called a population. A population could be defined as a number of different things. It could be all Year 12 students at Kew High School. It could be all Year 12 students in Victoria. Or it could be all Year 12 students in Australia. Often dealing with an entire population is not practical for a number of reasons. Firstly, the population just may be too large for us to get to every single member of the population. Or the population may be hard to access. You may not be able to physically get to and question every single person. Or it might be that collecting data from the entire population may be destructive. For example, if I was testing the life of batteries, then testing all the batteries in Melbourne could mean that there are no batteries left to use. Now let's have a look at samples. Often when we want to collect data from a target population, we often collect a sample from the population from which we can collect the data. The hope is that what we find out about the sample will be also true of the entire population. Therefore, samples need to be representative of the population. For a sample to be representative of an entire population, we need to make sure that any subgroup of the population isn't favoured or disfavoured. The best way to ensure this is to make sure that all members of the population have an equal chance of being selected in the sample. In this way, it means that all subgroups in the population have an equal chance of being selected in the sample. In order to do this, we choose the sample at random. This is known as random sampling. Let's look at random sampling. One way to select a random sample is to use a random number generator on a computer, a spreadsheet, or the CAS calculator. For our purposes, we're going to look at the CAS calculator, and when you are using your CAS, you need to open a calculator page and go to Menu, Probability, Random, and then Integer. Your screen will look like this. You can see here that we have RandInt, which stands for random integer, within the range of 1 to 18, and I'm going to select 6 in my sample. When I did this, here were the numbers I came up with: 17, 17, 3, 10, 8, 14. As you can see, the danger is sometimes a number can be repeated. After all, they are random. In this screen, I'm asking the calculator to come up with 6 random integers between the numbers 1 to 18 inclusive. So this command is to find 6 random integers between 1 and 18. And as I said before, we use the command randint 1, 18, 6 as shown. Let's have a look at a demonstration of how we do this on the calculator. The first thing I do is go to Menu. I then go to Probability. Then I go to Random. And then I go to Integer. See how I get the command randint here. So I want my random number to be between 1 and 18. And I want to select 6 numbers. Press enter, and here are my numbers: 17, 17, 3, 10, 8, 14. It's that easy. Let's have a look at the population proportion denoted by the letter P. Suppose that our population of interest is the students in my Year 7 maths class, and that we are particularly interested in the number of females in this maths class. Examination of the class group shows that there are 12 females out of 25 students in the class. This proportion is shown as a fraction, 12 out of 25. This is called the population proportion and is generally denoted by the letter P. So, for this particular population, P is equal to 12 over 25. The population proportion P is constant for a particular population. As a definition, we say that the population proportion P is equal to the number in the population with a particular attribute divided by the population size. In this example, the particular attribute was being a female. There were 12 females in the group out of a total population of 25. Now let's look at the sample proportion, denoted by the letter P with a hat. We call it P hat. Say I now want to randomly select a sample of 6 students from the 25 students in the class. I use the CAS calculator and the rand_int command to select 6 random numbers from the numbers 1 to 25. In doing that, here were the numbers that I got: 19, 1, 11, 8, 25, and 1 again. This means that the following students were selected for our sample. Student 19 was a male, student 1 was a male, student 11 was a male, student 8 was a male, student 25 was a female, and student 1 again, of course, was a male. As the number 1 came up twice, I will use the calculator again to select 1 student from the class. I did this with the following result. The random number I got was 21. This student happened to be a female. So therefore, I will add another female to the sample. So the final sample from the class looks like this: male, 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 and then 2 females. In this particular sample, we can see that the number of females is 2 out of 6 students. This is the sample proportion, and it's known as P hat. By definition, we say that the sample proportion, P hat, is the number in the sample with the particular attribute divided by the sample size. In this example, the particular attribute again was being a female. We had 2 students in the sample who were female, and the sample size was 6 students. Note the different symbols that are used for the sample proportion so that in future you don't get them confused. The difference between the sample proportion and the population proportion. Remember, the population proportion is P and the sample proportion is P hat. In this particular case, P hat, the sample proportion, is equal to 2/6 or 1/3. This isn't the same as the population proportion, which remains constant. In this case, P was 12 out of 25. There isn't a problem with this because each time a sample is selected, the number of females in the sample will vary. You may get a different sample proportion for each different sample that you select. And since P hat varies, with each random sample, we can consider the sample proportion p hat as being the values of a random variable, and this random variable is denoted as uppercase P hat. So by definition, the population proportion P is a population parameter, and its value is constant. The sample proportion P hat, however, is known as the sample statistic. Its value isn't constant because it varies from sample to sample. I now want you to work on exercise 17A from page 692 in your textbook. The questions I want you to do are 6, 12, 13 and 14. Have fun doing those examples.